Hello, welcome to another episode of Data Pancakes. And I'm here alone, so maybe you wonder, so where is Sarat? Well, Sarat is on holiday in India currently with his family and enjoying some time off. So to keep the show on and running, I've decided to do another session now myself. And the plan for today is to redo the session I've done previously for Dreamio Subsurface. And the session there was titled Demystifying the Medallion and Lakehouse Architectures. The session itself was quite popular and rated with a 4.7 out of 5. Lots of people reached out to me afterwards, whether it's possible to get the slides or have another look at that presentation or that session I've done recently. Well, and here it is. So I'm planning to redo it all myself. So, about a little bit about myself. So, I'm Piethein. I'm the Chief Data Officer for Microsoft the Netherlands. I've been working for ABN AMRO for quite some time, and in that phase or in that period, I also wrote a book you see here on the right, Data Management at Scale. And recently, also second edition of this book came out. Lastly, I'm quite active on LinkedIn, on medium.com. So if you would like to learn more about the medallion architecture of these different layers or how to make a metadata driven framework, for instance, all of these articles you can find on my blog post. And we have tons of, I think, other useful information on this YouTube channel. So on the medallion architecture, first the name. The name comes from that layering, bronze, silver, gold, so hence medallion. So that's where that word stands for. And I think it was Databricks who first coined that name. So it's Databricks first describing this architecture. But the way I see it, it's basically just a simple way of explaining how these concerns should be separated. And honestly, I think there's not really a difference when we compare this layering um, to the data warehouses we already have been designing and building since the late 80s. So also in that architecture, which we'll see in a minute, we decoupled these concerns of ingestion, staging, integration, and consumption usage, so via data marts. So if we have a look at that architecture, so this is a typical data warehouse architecture, and these architectures have been there for quite a while and are also relatively popular in supporting the decision processes when using data or business intelligence. Also, the characteristic here of a data warehouse is it consolidates data from various source systems, so in a central repository, what we call the data warehouse. And the decoupling with different layers is an important design principle. And this is mainly for retaining flexibility. So if we have a look at the bottom, so we see source systems. In those source systems, often the data is raw, quite technical, heavily normalized. And why is that? Because we would like to use the data in a very efficient way. So when we make updates, we would not like to do updates on many different places. So only update the data that is relevant or that matters. So therefore, we have this intent to heavily normalize that data. There might be an intermediate system sometimes in between, what we call an operational data store. So if we would like to do massive operational queries on the source system itself, it might be not ideal. So we take a copy and we offload and store that in a construct or another database we call an operational data store. So that's a convenient way of decoupling the performance concerns. In other cases, maybe we pull or we extract the data straight out of these source systems, and then we bring it to another layer, which we call our staging layer. So often this is a file share, or could also be cheaper, maybe relational database. On that environment, so we do lots of data quality checks. So we validate the integrity of the data before moving it into our data warehouse. And this layering is important because if we learn data is polluted, incorrect, or we yeah, cannot integrate it at a later stage, we have that decoupling, so the staging layer in that respect. Next, we move it into a data warehouse system. So in that, typically we have an integration layer in which we start to combine, unify all of the data from these different sources. There could be lots of metadata in that respect we use for that. So we make it dynamic, the whole data processing. And then at the end, we have a layer with our data marts. And this is mainly for decoupling the concerns of that integration layer and the consumption on the right-hand side. So we select subsets and we might maybe restructure the data for, I don't know, getting more performance um, out of the data, or we add some additional business logic for only those set of users or that user group on the right. And then lastly, there are reporting tools using that data from the data warehouse. And data warehouses in that period, so in the late 90s, we often used relational database management systems. So integrity is an important concern, and there's this notion of asset compliancy. So every update or change we make, there's a transaction log, so we could revert back in case we did something wrong. So on the next slide, so now why a lakehouse over traditional data warehouse? Well, we discussed that first generation architecture, but there was a second one we did not discuss, and these are called the data lakes, low cost, high volume storage environments with compute in which we can store massive volumes of data. So that's the second generation architectures often people refer to. And those architectures we can use for massively distributedly processing high volumes of data, both structured, unstructured. Also different here, we work with files, so we dump in data and then afterwards we apply a schema while we yeah, after when we start reading that data. And I think this is also contrasting to that first generation architecture in which you had defined that schema upfront, so before loading data into your warehouse. Now on the cloud these days, what I see is storage and compute are separated from each other, meaning so you can independently scale up and down. So you can bring in compute only when needed and when processing lots of data. And this makes the architecture also quite cost efficient, contrasting to that first generation architecture, in which if you had to scale up that architecture, both compute and storage um, were scaled up. So less cost efficient, you could argue. Also different from the traditional data warehouse is we work with open source table formats. Parquet and Delta are the most or the most popular file formats I see my customers work with. And what Databricks has done with Delta, they made some enhancements over Parquet, and they added a transaction log, versioning, schema enforcement, the evolution. And I think also this brings the lake more closer to a warehouse with these kind of features. So again, hence that name Lakehouse. And lastly, there's a compute in-memory data processing engine, um, also in this lakehouse architecture, and this supports a wider variety of different languages, so Python, Scala, SQL, Java. And this engine also allows you to do more just than just SQL or integrating that data, so you can as well do feature engineering, machine learning, predictions, data science, and use it for way more. So that in essence, I think, describes how lakehouses differ from the traditional data warehouses. So next, look into then the Medallion architecture using that lakehouse. How are these architectures then presented? So if you look at the Medallion architecture, simply high level, it's quite similar to the data warehouse. So on the left, you see the same source systems. We do the ingestion. We have that staging layer. We call that bronze. So it's often an one-to-one copy. So the raw technical files at that stage data is still unprocessed. So we see the identical structures of that source system. The partitioning, usually for that we create folders, and each time when we ingest that data, we create another folder, we dump in all those files, and we store it in our bronze layer. And then from there, we select that data, the relevant data, we filter out maybe technical or irrelevant data, and we bring that into another layer, which we call our silver layer. And in that layer, the data typically is cleaned, a bit filtered. We do some lightweight modifications. And that step, you could say, is quite predictable. So no complex, fancy business logic, for instance, just lightweight filterings and modifications on that data. And then what we will have in that silver layer is a nicely cleaned historical layer. And yes, data historization is also an important part of this layer. So often I see customers, they build slowly changing dimensions. So in bronze, we had the data layered per ingestion, but now in silver, we have everything combined and integrated. So there's a start and an end date, and you can nicely time travel also on that data. And then the last step is we select data we would like to bring to our customers or consumers. So we select subsets and we bring that to the gold layer. And typically, during that stage, we add complex business logic. So we ensure we meet the functional complex requirements on the left of those different consumers. And we use that data for then at the end reporting or data science. And we need to orchestrate also all of those steps. So therefore, you see an orchestration engine here in this example data factory. And this is the architecture um, that uses the Microsoft Fabric services. But it looks quite similar if you would do it, for instance, for Databricks or for other vendors. It's roughly it's just the layering. Where the confusion I see comes in is customers or partners I work with being too strict on the layering. So the architecture in itself could also look like this. So there could be, for instance, an additional landing area in between. So between the data platform and the operational source systems. And this might be, I don't know, convenient when you would like to decouple the infrastructure concerns. So maybe you would like to have a landing area close to the source systems where they reside on a different cloud or on-premise, for instance. Or you would like to give the application teams control over um, ingesting the data into a landing area instead of immediately dumping it straight into your data platform. So that's a concern and a way of decoupling additionally. Then we have that bronze layer again, but sometimes I see also the silver layer is split apart. So we have one layer in which we have that data from bronze, but slightly corrected, validated, lightweight modifications. But maybe there's another layer in silver where we um, conform perhaps to the next step of integration. So we rename columns, we do some mappings from local reference data to more enterprise or integrated reference data. We change the data types, etc. And I see customers, they separate those concerns, and that gives them some convenience over the way they process data. So that silver layer then is splitted into different layers. And the same you could argue maybe for that gold layer. So we have one then additional layer with all data integrated, combined, enriched, conformed. We apply massive unification on all that data. So we have one giant historic integrated layer and then another layer which we could call again an on top of the integrated gold layer, but then for the consumption. So that's where the data marts then would sit. So we take subsets and we make the data specific for the different users and consumers we have on the right hand side. So as you can see, so that architecture might in practice look really different with lots of additional layers. And I'm not going to discuss this in a lot of detail, but what I've done here, and I will share the slides as well after this podcast, is what I often see what customers do in that respect within all of these different layers. So the landing area, ingestion layer, well, you can read it for yourself. But we aren't there. So what other changes I often see? Well, nice. Now we have that roughly that high level medallion architecture, but you aren't there just with that architecture. You need to complement it often also with additional services. So maybe from bronze to silver, instead of writing everything down in notebooks, maybe you would like to make that process entirely metadata driven. So um, note down, record, so the source system schema structures, and you for that you build and design your own metadata repository. Lots of customers do that, and they use that metadata then in a metadata driven way, so declaratively in dynamic notebooks. So there's a generic notebook that pulls metadata from that metadata repository, uses that schema metadata automatically to validate against so data quality using a framework, for instance, like Great Expectations. So another example is maybe you would not like to get the logging out of the data platform itself, but you would like to do some trend analysis over logging information, or you would like to make that logging information externally available to also other domains or customers. So you could store as well that logging information in a logging database. So that's also something I see lots of customers do. You need to complement this architecture with the data catalog. So what data resides where, and the lineage and the consumption, and who uses what data for what purpose. So for that, perhaps data catalog. Or the data quality results. Maybe you would like to store these as well in an additional metadata or repository. So there on the right hand side, you see another repository. And maybe on that you would like to do reporting. So show trend analysis over data quality and giving users insights in how well the data is ingested, managed within this architecture. Maybe you would like to complement this architecture also with I don't know, and templating frameworks, so something like DBT. I'm personally quite fan of. So instead of building and asking teams to do lots of build lots of notebooks, so instead they use a framework. So to more pre um, scribely, so store the transformations, for instance. So using templates in that respect. And maybe that gold layer, that could also be a layer for distribution to other domains or teams that reside outside of this architecture. So in fact, you could have multiple of these architectures for different teams. So you start to instantiate more and more of these architectures. Another variation I sometimes see is that customers, they split the concerns of distributing data to other teams um, from the internal, so use case specific data. And why would you look like to do that? Well, if you have one gold layer and from that gold layer you distribute both to different domains, and as well you would use that data for use cases. Imagine a scenario where for those use cases you need to restructure that data or make changes, so disruptive changes to that data. It's likely then that external consumers will be impacted. So therefore, a best practice could be is you separate the concerns of distributing data to other domains from data usage, so the use cases within the domain itself. So you have an additional layer then in that respect. And often what I see is customers call that layer, so the distribution of data to other domains, they call that their data product data. So when we talk about data products, that's that layer then in that respect. Another variant of this architecture could be is we add the real-time ingestion part. So we use change data capture, or we ask applications to generate events, and we do event streaming within this architecture. We could even process and analyze that data. So we do windowing functions and we start to compare these events, and maybe based on the changes we detect and we see, we immediately might ingest that data in our lakehouse. Maybe while doing so, we could do lookups from that data lakehouse architecture as well. So we use the delta tables to do lookups and real-time enrichments on that data, and we push it back into the lakehouse architecture. Could be very well. Um, Sometimes I see customers, they complement the lakehouse architecture then with an additional relational database management system to have more predictable performance in that respect. If you do massive singleton reads, so you fetch constantly out single records out of your architecture, so your data platform, I think lakehouses aren't that great for that. So they are fast when it comes to big data processing, but not that great when it comes to fetching out single records. Um, Lots of times high concurrency is also sometimes a concern, lots of individual updates and writes, or maybe you would like to mix different workloads, or massive joins or unpredictable queries you might fire against an data platform. I think a relational database still is a bit better in that respect to a lakehouse or a data lake. um, The bronze layer, so another variant, the bronze layer could also be an aggregate or conglomerate of different ways you handle and ingest that data. So with Microsoft Fabric, now you could make shortcuts. So apply some lightweight data virtualization. In other cases, maybe you make extracts and you make exports and you import the data into this architecture. Or you apply mirroring, so real-time change. So you use change data capture, for instance, to build up a real-time identical copy of that data that resides elsewhere. And you could mix and combine these different patterns in parallel and then have an bronze layer. That's basically, again, a combination of different layers in which you see the data is handled differently. And then you bring it over to the next layer, the silver layer and the gold layer. And in that respect, I also have lots of customer conversations. So, for instance, in Microsoft Fabric, should it be one layer? No, you could create different lakehouse entities for these different concerns, or sometimes use a lakehouse entity for each source you onboard. So then the bronze layer is a collection of different lakehouse entities within Microsoft Fabric. And that all is fine and works really well. Another variant, so some organizations I work with, they are a bit, I think, more centralized in that respect. There's one larger team taking care of all the data ingestion, data engineering, building the use cases. So you could also opt for a larger, more centralized architecture. So in which you first stage all your data in bronze, you clean and integrate in silver, and then you have more that classic integration layer in gold. And that's, I think, quite similar to the traditional data warehouse. And from that, I think you distill data and you select relevant data for different use cases. And you have another layer for all of these different individual use cases. Question I often get, so how to model the data in the gold layer? Honestly, I'm a big fan of more denormalized wide nested tables. And why? Because storage and compute are separated from each other, and the storage is distributed. So within the Azure data center, we have lots of servers, and if you would use OneLake or ADLS, the data is distributed across many different servers. However, tables are combined and kept together on one single server. But if you start to brutally normalize that data and you have tons of small tables, then you see massive distribution within that decentral architecture. And that for data usage and when massively joining all of that data is quite, then you will learn an horrible experience you get out of that architecture, because you need to first start reading all of the data from all of these distributed servers within that distributed ecosystem. So my best practice would be is yeah, apply some more denormalization on the data. So opt for Kimball, for instance, so wide nested columns and tables in that respect. Another variant of that medallion architecture is, I see sometimes self-service is added. So we have a more stable production process in which we validate and lend that data in bronze and silver and gold. However, there are business applying self-service on that data. So we create another workspace, maybe perhaps in that respect. So we shortcut data, I don't know, either from silver and gold, and we allow these users even to upload or generate and create their own data in that respect. But that concern we would like to separate from the production process. So we have different workspaces and, yet again, additional layers in this architecture. We could also add application integration to this architecture. That's also sometimes what I see among customers. So we have the medallion architecture. We made a split for distribution also to other domains, but that layer from gold, for instance, we would like to give domains that reside elsewhere or users a better experience. So we um, duplicate that data, and I don't know, we store it in a document-oriented database, or we put an API gateway in between, or we give them virtualized access. Or when updating, I don't know, the silver layer, so we detect from the slowly changing dimensions, so what records we updated, from that we generated change feed. So we generate events out of our lakehouse and we distribute those events to other teams. So instead of copying all data, no, we do event processing and we only ship the changes we detected in our silver layer. So that's, I think, also a valid pattern I often see among customers. Or we put the API gateway additionally on top of this architecture, and we allow also consumers to read directly from the operational systems. And then you have basically two API gateways, one for the strong, consistent reads and for the commands, and another one for the more eventual consistent reads, and those you could serve from your data architecture. And I think that's a nice way of implementing CQRS within this architecture. We can also start to combine and integrate everything we discussed now. So here you see basically the combination of all of the different patterns and layers and things we have discussed so far. So these medallion architectures, yes, they might initially look simple, bronze, silver, gold, but in practice they could be very rich, like you see here on the screen. Another approach I see is where if we start to grow and we have multiple teams, we could tailor these architectures depending on the needs of a domain. So maybe looking from the source system side, we still use that medallion architecture because we feel it's important to validate and layer that our data extremely well. But from that gold layer or a distribution layer, we distribute data then to other domains. They again use a lakehouse architecture for that. But the number of layers might significantly differ between teams because the requirements will be different. So here in this example, you see, well, maybe one team has just one layer because they do some lightweight modifications on that data, and that's just it. And they use that. Or another team maybe just shortcut data, so apply some virtualization and do processing of the data then within that virtualization layer and would use that directly for, I don't know, reporting or data science. Or we have intermediate architectures in which we integrate and combine data. So we, for instance, we apply unification, but only on a subset of the data. So customer data, for instance, we apply some unification on that, and that's an aggregate or an intermediate new data product we ship then again to other teams. So we allow teams then to select so what sources they would like to select. Is it either data that comes from the original domain, or is it an intermediate that has some, I think, improvements over the data already? So again, the architectures themselves could look really different depending on the needs. And when you start to combine all of this and also the additional layer we discussed before, it's likely you end up with a very large end-to-end data architecture. So here you see multiple domains, horizontal teams, taking ownership over their applications, as well lakehouse architectures they use for themselves. They ingest data, they build data products, they share these data products to other teams. Other teams then again use these data products as well. They might shortcut that data or copy that data depending on their requirements. And we complement also these lakehouse architectures with additional services depending on what they need for their use cases. So maybe they do reporting as well, machine learning, or we store that data in an analytical store, or generative AI nowadays, I see more and more. So we will have this very rich end-to-end complex architecture. And on top, there's another layer, which is our data management layer. So we have lots of additional services, central services for controlling, managing this architecture, overseeing everything end to end. So the catalog, policies, a central metadata repository for, I don't know, capturing all schema metadata. We do central logging. We have, I don't know, GitHub repositories with best practices, frameworks, libraries we provide to these other teams. And at the end, I learned over the years, when scaling and establishing these kind of architectures, standardization on one hand is critical. And you need to think about building communities. So, for instance, in red, you see the data engineers, and that could form a data engineering community. And why is that important? Because all of these different teams have requirements, and you would like to achieve some standardization between these different teams. If all of these teams individually would opt for their own data quality framework, for instance, how would you then, as an organization, be able to do end-to-end data quality reporting or oversee data quality end-to-end? So it's important to achieve standardization. And in that respect, well, you need to work closely with, on one hand, the domain teams, on the other hand, the central or enabling team. So making it work, it's really a team sport. Well, so to recap, well, the medallion architecture, like we discussed today is a framework for data processing, but it's not a full, rich end-to-end data architecture. So you need to complement and combine it with other best practices. Lake houses, like we also discussed, combine benefits from the traditional data warehouses as well, data lakes, but they might be not ideal for teams that require, I think, brutal performance, do singleton reads, individual updates, require high concurrency or strong data integrity, for instance. Well, the silver layer we discussed often has clean, processed, historized data, and therefore I think it might be an ideal candidate as well for the operational data store. So you could consider, instead of using an operational data store always, also look at your lakehouse architecture and determine whether the silver layer also could accommodate for that. We also learned about the gold layer. I think that's the most complex layer because of all of the requirements we have seen. So it could be a single integration layers, an integration layer with data mart layer, distribution layer. But when you go beyond that, so you have multiple teams, so it could really look different depending on the requirements you have. Standardization, we learned, is essential, especially for interoperability. So we have lots of different teams. You would like to make it easy for those teams to share the data between one and another. And like we discussed and also concluded, a typical end-to-end data architecture is usually a blend or a mix of many different technologies. So yes, you could use a lakehouse for that, but likely you need to complement it with event streaming, relational databases, time series databases, IoT, generative AI these days. So it will be more and more. Well, thanks for watching. I hope you enjoyed. And if you like this podcast, please, I remind you, give a thumbs up and hope to see you next time. Thank you.